the Greeks discovered that if you want to find the trig function, the sine particularly, of a sum of two angles, you can find the sine of the first angle times the cosine of the second angle. Keep whatever sign you're doing, whether it's you're adding your two angles or you're subtracting the two angles, keep the same sign. And then how Mr. Messner likes to do it, cosine of the first angle, sine, second angle. I like to keep the angles AB, AB. You will see, for the cosine sums and differences, they are in AB, AB format. So I think what helps students to remember this is having it in AB, AB format. What I'm going to be repeating over and over and over again today is the following. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. I'll do it again. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. AB, AB. Sine, sine stays the same. Cosine, sine flips. Okay? Now I'm going to show you this in action. Now, this is how mathematicians had to find the ratios that exist in triangles that were unknown, triangles that were hard to figure out the ratios because you can't prove the side length. Until we got to calculus and we discovered like equivalent forms of the sine function, and we kind of had to throw this away. But we like to learn from our past, so we're going to do the Greek way of finding the sine of 23 pi over 12, not the calculator way of finding the sine of 23 pi over 12, which you'll learn if you take calculus. So we know that 20 pi over 12 plus 3 pi over 12 equals 23 pi over 12. Would you guys agree with me? That 20 pi over 12 plus 3 pi over 12 is 23 pi over 12. Cool. Would you agree with me that 20 pi over 12 is equivalent to 5 pi over 3? And that 3 pi over 12 is equivalent to pi over 4. Cool. We know what the end is going to be. It's got to be something that's like 0.2588. That's the sine of 12 pi over 3. Your calculator uses calculus to get that answer. Okay? So, how are we going to get this answer without using calculus? We're going to use the sum identity for sine. We're going to say, hey, I'm going to find the sine of 5 pi over 3 plus pi over 4 because I know this is the same as 23 pi over 12. Cool? Everybody write this down. And then the Greeks discovered this. They proved this. You're just going to take it as a matter of fact that if you're having a sum of two angles inside sine, you will have sine, cosine, cosine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. It becomes a dance. If I had a maraca, I'd shake it. If you see a plus, you keep the plus. If you saw a minus, you got options. If you saw a minus, you could keep the minus, or you could make it a plus or negative, and then make all your angles for B negative, but keep this as a plus. The angles go A, B, A, B, just like it would It's just how I learned it, so you usually teach things how you learn it the first way. I always teach the product rule in calculus the same way that I learned the product rule, and then like other people teach it a different way, and it becomes like I catch kids who go to tutors, and I'm like, yeah, you totally went to a tutor. They're like, how do you know? Because you did the product rule differently. And it's like, it's okay. Just reflect things a little bit. Okay, great. What happens now? Yo, trigonometry happens now. The unit circle, the sine of 5 pi over 3. You know that. Oh, 5 pi over 3. How do I figure this out? Oh, yeah, okay. Pi over 3 means this kind of triangle. 5 pi over 3 is here. Sine is the opposite over the hypotenuse, or it's just really the opposite. We're going to talk about unit circles and hypotenuse of 1. Do you know what the sine of 5 pi over 3 is? Write it down. What's the sine of 5 pi over 3? And this is why the sum and difference formulas, identities are used, because we have angles that create triangles that we know. 5 pi over 3 is in the 4th quadrant with a 60-degree reference angle. Or guys, yo, guess what? You know about ASTC? I mean, you don't have to use it, but 5 pi over 3 is in the 4th quadrant. The answer is negative. Pi over 3 is your tall 30, 60, 90 triangle, whose opposite side length is the larger side length in the 30, 60, 90. Okay, you could focus on the triangle that's really in the 1st quadrant, know that sine is negative in the 4th quadrant. You get negative root 3 over 2. We are just using trigonometry. Now, guys, this is why when I teach solving trig equations, I stay with the triangles. I don't use the dots. Let's try to keep stuff like as familiar as possible for as long as possible. We're using the same things for as long as possible so that we don't think we're learning stuff that's new. Solving trig equations, if you knew trigonometry using triangles, when you solve trig equations, you should use triangles. Okay? Write down, what is the cosine of pi over 4? Write that there. Use a triangle, please. Oh. Or get the right answer because you have the triangles in your head. Or get the right answers because you memorized the unit circle like some people do. Great. You use triangles? Great. Appreciate it. Triangles in your head is great. Then, please tell me, what is the cosine of 5 pi over 3? Write that down. And then finish off with the sine of pi over 4. Write that down. You should have all 4. They're either in your head or you are writing your triangles down. These are the triangles that you know and love that you should have been using when you're solving trig equations. Okay, nice. You got it, Collie? What's going on? We'll see how we'll want it simplified a little bit more. No, that's not right. What? Yeah, just, can you keep going for me, please, and find some trig functions with some angles? Yeah, thanks. Thank you. Appreciate that, Doc. Looking good, Tempest. Thanks, Sheriff. Great question. Yes. Okay. We all remember our 45, 45, 90 triangle. We all remember the adjacent side length in the 4th quadrant of our pi over 3 is positive a half. We all remember the sine of pi over 4 is the same as the cosine of pi over 4. Great. I'd love if this could be our answer, but we can simplify this. First things first, if you know the square root of 3 times the square root of 2 is equivalent to the square root of 6, that's great, isn't it? The way I remember this is like root 2 times root 2 is just 2. Well, it's like root 4, which is 2. Okay, so I can multiply root 3 and root 2. So I'm going to get negative root 6. Don't forget, that's a 6. Don't forget to multiply the denominators together. We are multiplying fractions, so we like have to take a half of a half. So we get a fourth. So I get negative root 6 over 4. If anything I forget to multiply the drop. Then we get 1 times root 2 over 4. And we get that. Now, root 6 plus root 2, or negative root 6 plus negative root 2, is not root 8. For example, you could use like root 6 plus root 3. You're like, oh, root 6 plus root 3 has to be 3. It's not. So we can't add roots together. We can multiply roots together. So if I were to simplify this one extra step just to make it look a little bit nicer, because that's what's expected of you, you would combine your numerators just by adding them together, and then over your common denominator, making sure you know this is a negative root 6. Sine, cosine, cosine, sine. AB, AB. Keep the same sign. Now, your calculator uses a numerical process, probably using the idea of a Taylor series to get this answer. You will learn about the Taylor series next year. But mathematicians, until calculus was invented, had to use the sum and difference to find ratios of interesting triangles whose side lengths were unknown or could not be proven. There is that answer, negative 0.2588. Okay? We could do the same thing with cosine, a cosine value. Cosine, cosine, sine, sine. Now, here's some things that really trip up some students with the sum and difference formula. First of all, you should understand pi over 4 is the same as 3 pi over 12. Pi over 6 is the same as 2 pi over 12. 3 pi over 12 minus 2 pi over 12 is 1 pi over 12. So that's why pi over 4 minus pi over 6 is pi over 12. Don't ask go to the bathroom. What do you got? What? No, go ahead. The previous one? Yeah, I did. Root 3 times root 2 is root 6. Okay.
So, like, wouldn't root 2 times... Oh, wait, wouldn't root 2 times root 2 be
root 2 plus root 2 is 2 root 2. Okay. Root 2 times root 2 is just 2, but really it starts as root 4, which is 2. Okay? Okay, so we're good with that. So we know that if you want to find the cosine of pi over 12, now first thing is first, don't do the work. Think about the triangle. What type of value should we get for the cosine of pi over 12? Tell your neighbors. Tell me what type of value should you get for the cosine of pi over 12 if you're talking about a 15-degree angle. Give me an estimate. This is mathematical thinking, guys. Give me an estimate for the cosine of pi over 12. If you divide by more things, it becomes less. So you got to be careful about cosine's maximum value. Who's got an answer? Give me something. Throw some out there. Let's take guesses. Go. Who wants to take a guess? What's the cosine of pi over 12? Take a guess. Come on. Give me a decimal. 0.9 is a great guess. Thank you, Diallo. Any other guesses? Do we think we're closer? Could it be 1.2? Why not? Can't be greater than 1. The cosine of 0 is 1. Cosine's maximum ratio is 1. When the adjacent is 1 and the hypotenuse is 1. 0.9 is a great guess. Let's see what it really is. Now let's go the Greek method, where they didn't have calculators. They just had to trust in their proofs, which were correct. cosine, cosine, sine, sine. Now I'm doing it a little bit differently here because I have pi over 12. I'm going to be like, oh yeah, pi over 12 is the same as pi over 4 minus pi over 6. Now, two things you could do. Either keep the angles both positive. Murph, am I just kicking you out? Are you going to that half? Files? You're good? You good? Okay, you good? Cool. Keep the angles positive. Change your sign to be a plus, because cosine, we flip the sign. Or you can write it as cosine pi over 4 plus a negative pi over 6. A lot of students like to always think about plus and negatives. I do as well. If you were to do that, cosine, cosine, sine, sine, what would happen is that this would be positive pi over 4. This would be negative pi over 6. This plus turns into a minus. You're going to get the same result. Whether you keep both angles to be positive and you flip your symbol, your addition, your subtraction symbol, subtraction turns into an addition, or you change it to plus and negative, you still have to flip your symbol, but your angles are the opposite. Get your answer, get it simplified. You get it right? What's your question? Yo, 0.96 wins. It's that close to 1. Nope.
Yeah, I think you had a minus in the middle and made both of these negative.
No, I did them plus. If this is a minus, that turns into a plus. If this is plus a negative, then this plus turns into a minus, but this angle stays as negative. These are the options. You're going to get the same thing.
Well, I can just do it originally. At the top.
Murph, I'm telling you, after seeing students who love to change subtraction into plus and negative, they would have to use this way if they change it to plus and negative. Okay? Can you keep the top? Sure. You don't have to change it to the bottom. I'm just saying, these are your two options.
Oh, I didn't look at the
Yeah, so, reminder, sine, cosine, cosine, sine. Sine stays the same. Sine, cosine, cosine, sine. The sine stays the same. Cosine, cosine, sine, sine. The sine flips. Okay? I showed you in the example, like, you could either flip the sign from a minus to a plus, because that's what you have to do. Thank you, Greeks, for proving it. We're not going to get into that. But you can find the proofs online if you want to.
I just completely didn't read that. I didn't read that at all.
Your answer is root 6 plus root 2 over 4, which is 0.9659. It's very, very close to 1. but not equal to 1. Okay? So, we got root 2 over 2, root 3 over 2, plus. It started with a minus, it becomes a plus. Root 2 over 2, and then this is a half. So this is root 6 over 4 plus root 2 over 4. All right, go to your homework. Do question number 1 and 2. First things first, there's a little typo. This should not say 7 pi, this should say 11 pi over 12. Now, they're helping you out. They're telling you that 11 pi over 12 equals 8 pi over 12 plus 3 pi over 12. Well, 8 pi over 12 can be simplified to an angle that you're used to. 3 pi over 12 can be simplified to an angle that you're used to. Divide the top and bottom by 4, divide the top and bottom by 3, get an angle that you're familiar with. Then you realize, oh, 2 pi over 3 plus pi over 4 equals 11 pi over 12. This is going to be positive, but very close to 0. My guess is it's root 6 minus root 2 over 4. This is going to be very negative. My guess is negative root 6 minus root 2.
How are you?
That's 3 pi over 2. Oh, sorry.
Something happened on number 1 and number 2. Nope. What's the cosine of 2 pi over 3, did you go to?
Are you proud of me, Mr. Messer?
Stop telling me no, because I don't know if I'm actually correct. Make me think I'm
Way to go, guys.
And
Pretty much. The way we're setting it up. Yeah.
Yeah, because that flips proper.
Because we're always giving you pi over 12. We're always giving you combinations of pi over 3s and pi over 4s. Really, pi over 6s and pi over 4s. Means you're going to end up with the same, similar results all the time. No, there's a different formula. No, thankfully we don't. But it really is like the sine identity divided by the cosine identity. What is the cosine of 2 pi over 3? Because a lot of people forget it. Thank you. Here are the answers. You should get positive root 6 minus root 2 over 4. You get negative root 6 minus root 2 over 4. You should find, and you will discover when you do the rest of your homework, it's going to be a lot of root 6s and root 2s over 4. Just the right combination of things. But you still need, no, that's not right. You still need your unit circle knowledge. You still need to remember what trig functions are positive. Where many of you are failing at that venture. Sine, cosine, cosine, sine. Cosine, cosine, sine, sine. Sine of 2 pi over 3 is root 3 over 2. The cosine of pi over 4 is root 2 over 2. The cosine of 2 pi over 3 is negative a half. Don't screw that up. Sure. We're about to learn new stuff. Sure. Yes. Just go. All right, back to the notes. The rest? Good. Actually, let's go to number 7 for me, please. Yeah, everybody forgets the cosine of 2 pi over 3 is negative a half. Okay.
Oh, yeah.
Number 7. What do you do? That should be 2. This is a 2. That'll help. All right, pause. I don't want us to do it. It's repetitive, but I want us to realize it's the same thing as what we just did. The cosine of the angle equals the adjacent over the hypotenuse. What if the hypotenuse wasn't 1? What if it was 2? Okay, this becomes 2, which means you'd have to double the cosine of your angle to get x. The whole scaling idea of things. Similarity in triangles, so important. And the scaling, so important. So, x equals the cosine of pi over 12. It's really cosine of pi over 12 adjacent over 1. So akatoa is always going to be there for you. I just can't say it normally now. It's like one of those like ticks, you know? I'm just joking. I just like to say it that way. And you just do cosine, cosine. What symbol goes in between the cosines and the sines? Files. What symbol goes between the cosines and the sines? Thank you. You flip the sign. We know pi over 12 is the same as 3 pi over 12. minus 2 pi over 12. 3 pi over 12 is pi over 4. 2 pi over 12 is pi over 6. You end up again with root 2's and root 6's and all that fun stuff. Y would be the sine of pi over 12, and you would do the same thing. Let's not spend time doing it. It's nice to be able to check your answers if you have a calculator. And like, as you're doing your homework, if you want to check your answers, yeah, go ahead and plug it in to your calculator. What does your calculator say sine of 11 pi over 12 is? Bam. You find it. Bam. Are you asking to go to the bathroom? All right, cool. What's up? No, of course not. It's one of those like confidence building exercises where it's like you feel like you got the right answer, you double check it, bam. All right. These are all the same. This needs to be scaled. Y sine of 5 pi over 12 would equal the opposite over the hypotenuse, which means multiply everything by 3. Scale things by 3, and you're good. Don't copy this down. Go back to your notes. We'll learn some new stuff. Don't copy that down. You'll figure it out. It's all the same. Whether it's in a unit circle or scaled into a bigger circle. Thanks. All right. Guess what? There are more identities that you have to know. What's the one identity that you know already? Tell your neighbors. What's the one identity? What's the one identity you know from day 2? The Pythagorean theorem in the unit circle with a reference angle. Cool. This is the Pythag identity. You now know 2 more, which are the sum and difference identities. If you know those 2, well, it's really 3. It's like sine and cosine's identities of sum and the Pythagorean identity. You should know every identity. The secant squared identity, boom. You know the sine squared plus cosine squared minus equals 1 can be manipulated. An identity for what cosine squared equals, boom, you know that. If you know the sum and difference identities, you should be able to know the double angle identity. These are the last identities that we need to learn, but again, it's not like you memorize them. If you know what sine of x plus x equals, you'll know what sine of 2x equals. So please, sine, cosine, cosine, sine with x and x for me, please. Oh my God. Please write the sine of x plus x out using the sum identity for sine, like you just did on your homework. And back to the notes. Oh my gosh.
Wait, Mr. Best.
Sine of 2 angles being added, sine, cosine, cosine, sine. No, it's just x's. Okay? It's just like how you're going to know what the double angle identity is. Can you fill in the angles? Okay. Cool. Cool. Good. We fill in our angles. We keep the same stuff. Now, guess what? This can be simplified. This can be simplified to produce your double angle identity. which I don't want you to memorize. Rather, understand how this is equal to what we're going to put down here. Now, somebody's going to tell me what this is simplified. Somebody? Shafia, what did you say? Thank you, Shafia. Shafia says, okay, I got one sine x cosec. I really have another sine x cosec, so I guess I have two sine x cosec. Thank you, Shafia. Isn't it? This is called a double angle identity for sine. Sine 2x is equivalent to 2 sine x cosine. Now, I'm just going to tell you guys this. In the short term, you could have this memorized. Okay? Fine. But in the long term, your very own teacher here does not have this memorized. Instead, tries to limit the amount of things he has memorized. I understand the sum and difference one. The whole sine, cosine, cosine, sine. You know, you make a little dance out of it, that's easy. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. You know, and all of a sudden you're walking home and you're having a good time, okay? Sine, cosine, cosine, sine, cosine, cosine, sine. And I just think about if I just have the same angle in my sine, cosine, cosine, sine, then I have two of the same thing. I have two sine x cosine. Got it? So, memorize it if you want, or keep this in your head and know how to produce this. I think it'll help you. Well, let's find the double angle identity for cosine. What's cos 2x equal to? And have it simplified for me. Nice. Go. Write that down. Figure it out. Sine, cosine, cosine, sine, cosine, cosine, sine, 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 cosine, cosine, sine, cosine, cosine, sine, sine. It's just a formula, which unfortunately doesn't have to make sense. You just got to use it. You want me to show you the proof, and then you can see if that makes sense? That's a whole other story.
No, I said it is like.
Good, good, good. Cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. Flip the symbol with cosine, keep the symbol with sine. X, 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 X. Oh my goodness. This is cosine, not x squared. We like to say it's cosine squared x. That's quantity cosine x squared. Minus sine x times sine x is sine squared x. We like to write it that way. Or it's quantity sine x squared. Oh man, I really want to simplify this and make this a 1 or a negative 1. But it doesn't. Sine squared plus cosine squared is 1. Manipulate this so you get cosine squared minus sine squared. Go ahead. You can't. You can't. Subtract sine squared. Okay, it's 1 minus sine squared. Okay, well, flip both sides. Okay, well, then it's negative, and that's a negative. Yo, all you can do is replace one of these two with what its equivalent. You want it to simplify more. It feels like it should be equal to 1 or negative 1. It's not. It just is what it is. Cool. Now how are we going to use this? This equation, I almost like And then I put a 4 underneath this 1, and then I'm like, okay, that's good. Cool? Cool. Put a 4 underneath that 1 there, Barry. Now, we are going to use, and usually you're going to be told, like they try to hook you up on the AP exam. They're going to say, hey, use the double angle identity for sine to solve or find the general solution to that equation. Okay? Cool. And you're like, all right, I know the double angle identity for sine. Sine, cosine, cosine, sine. With x. Sine, cosine, cosine, sine. With x. Keeping the plus is 2 sine x cos x. Cool. So I'm supposed to use this somehow to solve this. All right, tell your neighbors, what should you do? Come on, try. Be a math student. Solve a puzzle. Figure it out. What do? Be a math student. Try some things. Don't just copy things down or memorize how to do certain questions. I am told to use this to solve that. We got sine 2x equals 1/2. How did you get that, Diallo? That's brilliant. How'd you get it, Diallo? No, he's got it. Perfect. There are two ways to have these work with each other. Both ways involve substitution. You got to be comfortable with substituting. Okay, well, I have sine x cos x. I have sine x cos x times 2. Multiply this equation by 2. It's 2 sine x cos x equals 1/2. Boom. 2 sine x cos x gets replaced with sine 2x. One way. Blanchard, what were you thinking? Blanchard said, let's take this and divide it by 2. And now I have sine x cos x equals sine 2x over 2. You replace sine cos x, sine x cos x with sine 2x over 2. And then multiply by 2. You're exactly where Diallo was. Whatever you want to do, guys, just got to work with one to help you get the other. My probably first instinct was to manipulate this equation. And then, oh, nice. So you multiplied the 4 back, and then you multiplied these by 2. All right, cool. We're all going to get to this spot. Eventually, sine 2x equals 1/2, right? Cool. Perfect. Now, I'm going to put on some background music. Now, I want the general solution. That means all of the possible solutions, okay, to this equation. Sine 2x equals, how does Spotify work these days? Is it open.spotify? Who knows? Okay, I want all of the solutions to sine 2x equals 1/2. Here comes some background music. Okay. This is annoying. Wait, I had my username. Okay. Solve this. Please. Isha, you're such a sophomore. At least you're not a freshman. All right, so I want all the solutions. You're so close. You got 2 solutions. I want all the solutions. I need that coterminalness. That's then manipulated. Don't let me down, team. Don't let me down. Don't let me down. Day 1. Don't let me down. Oh no. Oh no. What are you doing? Oh no. Oh no. Come on. The trig function of some angles equals a ratio. Sine's my trig function. These are my angles in here equals the ratio. Pretend like this isn't even here. Worry about it later. Maybe think of it as a theta. Can you at least solve that? No. Well, yes, but no. Yes, but no. You have, right. No, you guys are all letting me down.
Give me a second, man.
I'm giving you a second.
There's my second.
I want all the solutions. No. All the solutions. All the solutions. You haven't manipulated your solutions. Those are your angles that need to be dilated. You need to solve for x. Oh, Zara. Right. Well, replace the angle with 2x. 2x is theta. Solve for x. No. Yes, Jolly, thanks. Oh, Jolly, she's on. Oh, man. Yo. Yeah, but still shit, man. You go to the bathroom, come back, and let me down. All right. All right. All right. Many of you let me down. You forgot so quickly. Trig function of an angle equals a ratio. You have the trig function, you have the ratio, you need to find the angle. You need to find the angle, and then you need to find the solution for x. You need to dilate horizontally. Sine, Torah, opposite, the y, 1/2, short, 30, 60, 90 triangle, pi over 6. Where is sine positive 1/2? In the first and second quadrants. We want the pi over 6 here. We want the pi over 6 there. I'm disappointed so few of you got at least there. That's your angle, pi over 6 and 5 pi over 6, and all coterminal angles to those. But my angles are represented by doubling x, which means to find what x has to be, I need to divide by 2. Horizontally dilate. Do the opposite of what you expect, which makes sense because we're solving this equation. You got pi over 12, pi over 12. Good job. So much disappointment. What?
an urge to go up to someone in public and just say, why are you following me? That'd be pretty funny, guys.
All right.
So soft.
Go to your homework. Let's do some hard problems.
Taking my phone. I don't like that.
You don't need it.
Yeah, I do. I'm a good student.
17, go. Now,
I know.
Crawford, your brother is walking in here like he owns the place. Such a Crawford. Not like, oh, hi, sorry, excuse me. I know him. I guess it's cool. All right, 17. They're hooking you up. They're telling you, hey, use the double angle identity with sine to solve this equation. They're telling you. So you probably should write down what the double angle identity for sine is. Now, oh, I forgot what it was. Oh, maybe it's in my short-term memory bank. Or maybe sine, cosine, cosine, sine can be used to help me. Sine, cosine, cosine, sine. Oh, yeah. The double angle identity is when we have two sine, cosine. This is what you can do to create this identity, not try to memorize it, which will only stay in your short-term memory bank, and it'll never be able to be reproduced after like a month off. And we're going to have the AP test in May, okay? So here is the double angle identity, which can be produced by you. You then try to figure out how you can use it. Go. No, you're not dead. Do this. Wait till we get to a really tough problem. This isn't even tough.
Wait.
To chill? To chill? That's hilarious, bro. Chilling. Yo. Other teachers say, hey, you got 20 minutes to work on your homework. Most students then chill during that time. I'm not that kind of teacher. Guess what? We're working on homework right now. That's your problem, Paul. Not my problem. If you don't know how to do this, then just do it. Look, Murph's on the right track. Just doesn't know what to do. What do I do now, Murph? Thank you. Look, you guys make a good team. You guys should be friends or something. I know. All right, great. We remember day 2. We got 2 terms. They both share a cosine. We factor out the cosine. We solve the equation. Cos x equals 0. Sine x equals -1/2. I get the solutions, the verticals. I get the solutions, the pi over 6s in the 3rd and 4th quadrants. And if you can't figure this out, you use your triangles, and you use ASTC, or you use your dot, whatever dot method you want to use, don't care. Okay, so you will be told to use a specific identity. Let's go to question 15. It's 408. Oh, yo. The key to this problem is that the sine of alpha is the y coordinate here. The cosine of alpha is the x-coordinate here. Keeping that in your mind, how it's like unit circle, sine is just the y-coordinate, cosine is the x-coordinate. You can make your triangles. You will be able to understand this problem if you know that fact. Good luck out there, students.